So we're going to be doing three algebra review topics, kind of all centered around a skill called factoring. And factoring is really important in the upper levels of math, starting in particular with Algebra 2. We're going to be doing a little review of algebra for the next 3 days, in particular some factoring. Factoring is used a lot in the higher levels of math. In Algebra 2, which all of you need to take, you'll be doing quite a bit of it. We're just going to focus on some review from your exponential algebra courses. So before we start factoring and a little warm up over here, we need to remember how to multiply a polynomial by a monomial. And we kind of know that we do the distributive property. Remember that when you multiply, you add exponents on like bases. So on this first term, when I multiply a to the first into 3a to the first, I'd have 3a to the 1 plus 1. And then 7 times a. And that's called the distributive property. And we've done that before. So on the next one here in purple, when I multiply this in, I have to note that there's a little 1 right here and a little 1 right here. And on the first half, I get a negative 2m to the 1 plus 2 is 3. And then a negative times a positive would be a negative 12, m to the 1 plus 1. And then on the last half, a negative times a negative is a positive, and we'd have a 2m. So I would like you on the next one to go ahead and put little ones, I'm going to do that in yellow, on these y's, because when you can't see the exponent, x actually means x to the first. When I ask you how old you are, you wouldn't say 15 to the first, but if you had to write it with a power, that's what it would be. So when I multiply this in, I'd get a 4x to the, and then remember you add those exponents. So it would be x to the fifth. And then we'd have a y attached with that as well. You can put a little 1 there if you want to. And then a minus 8, and we'd have an x cubed y to the 1 plus 1. So what we're going to be focusing on is taking these polynomials and factoring them. So we're going to be going in reverse. So if you had 8x squared plus 4x in simplest form, I can't combine those, they're not like terms. In factored form, I'd say, well, what can I pull out of both of these? In particular, what's the biggest number that goes into 4 and 8? And we'd say 4. And what's the biggest amount or the most amount of x's I can take out? And I can only take 1 because that's all this term has to give me. And then I actually factor or divide those out, leaving me with a 2x plus an x. And notice if I distribute it in, I get 8x squared, score, plus 4x. And do you see how right there I'm getting an x to the second? I did that on purpose so you can see, wait a minute, if I already pull 1x out of here, I wouldn't have any left. And some kids are just tempted just to leave it like this. But you need to be sure that when you multiply that 4x in, you get it back. So you need a 1. So we're going to be working in reverse. If we can't factor it, it's like a number that we can't break apart, like 7 or 13 or 19. We call those prime numbers. We also have what are called prime polynomials, where if that had been 8x to the fifth plus 5y, it's prime. There's no numbers that I can divide out of both 8 and 5, and I can't remove any of your x's and y's from both terms. So our steps for factoring are we have to identify that GCF. What is the biggest number that I can pull out of the coefficients? The coefficients are the numbers in front of the variables. For example, 5xy, the coefficient is the 5. So the first thing we do, let's go do that with number 1 down here, is we say, is there any number that I can divide out of both 3 and 12? And the answer is yes, I can pull out a 3. So I'd say my greatest common factor of the coefficients is a 3. Then what I do is I go look at those variables, all the x's and y's and p's and q's. You have to have that variable in all the terms to be able to pull some out. You'll notice I have x's here, but none here. So that means I can't pull any x's out. Okay, so what I'm going to do is say, well, my GCF is 3. And really what you do is you divide it out of both terms. So I'm going to go divide by 3, divide by 3. And what's left would be an x plus 4. And I can always check it with my hippity-hoppity distributive property. Like on this one, when I checked it up here, when I did this guy up here, I got 4x squared back. I'm like, I just need a 4x. So you can always check it by distributing. And I'd have 3x plus 12. We're going to move down to the next odd one here. I'm going to have you do some of the evens on your own. We need the biggest number that goes into both 8 and 36. Some things to help you is if the numbers are both even, you can always divide out a 2. If the numbers end in a 5 or a 0, you can take out a 5. If they add up to a multiple of 3, you can divide 3 out. There's lots of little rules, but basically you'll know if you didn't find the biggest one, and I'll show you how. So let's go look. These are both even, so I know a 2 goes in. But when I do 8 divided by 2, I get a 4. When I do 36 divided by 2, I get an 18. They're still both even, and they still both have a 2 in them, which means there's a bigger number, and that number would be 4. So my GCF is a 4 that goes into both 8 and 36. Do I have m's in both terms? Nope. Do I have n's in both terms? Nope. So the only thing that I can divide out of both terms or undistribute is a 4. So I'm going to put the 4 out front of the parentheses, and then I have to put back in what I need. Some people can just see it. Well, I need 2 and m to make the 8m. And I need 9 and n to make the 36n. That's fine. Or you can actually physically divide them both, and you'd still get a 2m plus 9n. So let's move on to one where we can pull some variables out. Let's go down here to number 7. So the first thing I do to find my greatest common factor is I think of 3, and I ask myself, does it go into 21? And the answer is yes. So I always go to that smaller one. Like here I say, does 6 go into 27? Nope. But 6 also has a 3 in it, and 3 goes into 27. So on this one, I'd say, does 3 go into 21? Yes, I'm going to be pulling a 3 out. Do both terms have c's in them? Nope, so they can't give me a c, but they both have d's. And what's the most that they can give me? They can each only afford to give me 1d. Even if this had been d to the 5th, they each can still only give me 1d. So you actually take the smallest number of variables out, like the smallest exponent. So let's go divide out our 3d, and let's undistribute it or divide by it. So instead of hopping it in, we're yanking it out. And when I divide a 3 out of 21, I get a 7. And when I divide the d out, the d's cancel, and I just have a c. Notice when I distribute that back in, I get 21 CD. Pretty cool. And then I'll have a subtraction. Now I need to get all of that back. You can't just leave it empty there. Picture dividing it by 3d. It's something divided by itself, which always gives us a 1. All right, moving down to number 9. Does 15 go evenly into 30? Yes. So my GCF is equal to 15. Let's go look at number 8 and kind of talk about that. Does 14 go evenly into 18? No. Does 7? No. Does 2? Yes. Or they're both even. So this would have a GCF of the coefficients of 2. So I can take a 15 out of both terms. They both have a's in them, but the smallest amount is a to the first. So that's all the second term can afford to give me. They each both have a b, and in particular, b to the first. So my GCF that's going to get pulled out is going to be a 15ab. And I'm going to be dividing that out. And when I divide the 15 out, I get a 1. You can write that down if you want. When I divide one of the a's, it's going to cancel 1 on the top. So I have 1 left. And the b is going to completely cancel the b on the top. So I would have a 1a left. Then I need a -2, and then that's all I need because the a would cancel with the a and the b with the b. And again, you can always check with the distributive property. One more together, actually two more. Then I'm going to have you go practice some evens and fill some of those answers out in our Ed puzzle. So let's go down to number 15. What number can I pull out of 2 and 2 and 4? They can all afford to give me a multiple of 2. So 2 is in my greatest common factor. Then I'll go look at the x's. Does this term have some? Yes, it has 2 of them. Yes, 1 of them. Yes, 1 of them. The smallest number I said is how many I can take out of all of them. This has a y to the first, y to the second, y to the first. I can take out a y to the first. So my GCF is a 2, x to the first, y to the first. And I'm going to go divide that out to determine what I need to put right here. Or you can just see it. I have the 2. I'll need another x to get x squared. And I have the y. I need a minus. I have the 2. So I just need a 1. I have the x. I'm good to go. But I'm going to need another y. So you can just create it as you go as well. I don't have the 4, so I'm going to need the 2. But I have the x and the y already in my GCF. And then I could check it by hippity-hoppity, distributive property. Let's go look at number 21 next. I want you guys, after I decide the GCF of these coefficients, what goes into 1 and 5, basically just a 1, and 1 doesn't really do anything, so I'm not going to write it down. You decide how many m's they can afford to give you. Remember, you grab the least number, the least power, and the power, and that is a 1 on the m. So they can all afford to give me 1 m. How many n's can they afford to give me? This one has 1, this one has 2, this one has 3. So they can all afford to give me only 1. You take that smallest number that they have in common. So on this one, my GCF is an m and an n. Boom, boom. Let's go see what I need. I have 1 m. I need 3 of them. I need 2 more. I have 1 n. There's only 1 n. I'm good. I need the subtraction. I have 1 m. I need 2 of them. I have 1 n. I need 2 of them. I need a plus. I need the 5. I have the m. And I need n to the third. So I'll need n to the second. And again, you can distribute that back in to check it. So the last one I want you to do in full on your own. So number 23, pause the video and go ahead and do it. Now that you're back, let's see how you did. What number goes into all of these? And first I'm going to grab that smallest one, the 15, and I'm going to ask myself, does it go in evenly to both of the other two? And the answer is no. Then I think of, well, 15 ends in a 5. 5 goes in it. Does 5 go into 20? Yes. Does 5 go into 35? Yes. So I will be pulling out a 5. Let's go write that down. Do they all have A's to give me? Yes, yes, yes. The most they can all give me is one of them, the smallest exponent of all the A factors. And then do they all have B's in them? No. So I can't, this first term and this last term, they can't afford to give me any B's because they don't have any. I can't remove them if they're not there, right? So let's go pull out a 5 and an A. We really kind of think of dividing it out. Or what do I need to get to 35? And you'd say, well, 7. What do I need to have 2 A's? And you'd say another one. What do I need to get a subtraction? A minus. What do I need to get the 20? A 4. What do I need to get the A? Nothing. I got it. What do I need to get the B squared? 2 more B's. You fill in this last number, and hopefully you said, well, I need 3 and no more A's. So that's called factoring out a GCF. Right now, on your own, before you go to work, I'm going to have you complete numbers 14 while answering some questions. And I like number 20. And let's try 24. Let's see how you did. What goes into both 18 and 48? Does 18 go evenly into 48? Well, if you don't know, you could go 48 divided by 18 on your calculator and you'll get a decimal, so it doesn't. What's the next biggest thing that goes into 18? And that's a 9. Does 9 go into 48? No. You can check it on your calculator if you need to. I do see that 6 goes into both of them. So that's my greatest common factor of the coefficients. They all have an A to give me. They both have a B to give me. And they can both afford to give me 2 C's because 2 is less than 3. And I picked that smaller exponent that they have in common. So 6ABC squared is my GCF. And then I divide it out, or you can picture what do I need to multiply it by. Doesn't really matter. 6 times 3 is 18, or I could think 18 divided by 6 is 3. I will need another A to go with this one to create the A squared. I have the B to the first, so I don't need any more of those. And I have the C to the second. I don't need any more of those. I'll need a minus, and I'll need an 8. To get the 48, I have the A, I have the B, I have 2 C's, which means I'll need one more of them. Or if you don't like that method, remember you can always just say, I'm going to divide each of these by my 6ABC squared. 6ABC squared. And you can just say, well, that's a 3. These will cancel, leaving an A. These will cancel. These will cancel. So there's your 3. All right. The next one up. Let's see, you should have pulled out 18 is the smaller one. It does not go into 24. What else goes into 18? 9. That does not go into 24. 6 goes into 24 and 36. So it looks like I'll be factoring out a 6 or dividing a 6 out of all those lead coefficients. X squared, x to the first, no x's. Can't pull any out. Y, no y's. Can't pull any out. Looks like they all have a z that they can afford to have chopped out though, so let's take out a z. So I'd have 6z, and then I'd need a 3. I'd need 2 x's and the y. Minus 4, I need the x. And I'll need another z. Again, if you want to picture dividing, you're dividing by 6z. This would cancel, leaving a 4. The x won't cancel. 2 of these, one's going to get cut off. So it depends on what you like better to think of. What do I need to multiply by, or what do I get when I divide? So what do I need to multiply by to get the 36? I think I need a 6. And then I'll need the y, because I don't have one in my GCF. I have one of the z's, but I need 3. So, or you could picture dividing a z out of z cubed, and you'd have z to the second. And lastly, because this will be the last one, I said 24, but I don't think we'll go there. Let's go check it. 18, score. X squared, score. I have a y, yes, and I have a z. I have the minus. 6 times 4 is 24. I have the x right here. I have the z being multiplied in with the z, so I have the z squared. I have the plus right here. 6 times 6 is 36, so that's good. I'll have the y in there. And my z times my z squared is z cubed. So if I hopped it back in, I get it exactly back. So basically, you're doing the undistributive property. That's it. Have a good one. You should now go work on worksheet number 1 until that is completely finished.